So what assignments for chapter 9 do you have to do?
You have to do everything except the 9.2, 9.3 one. You don't have to do the last 3 problems on the 9.4 assignment.
So what is that, 9.1?
9.1, 9.4 minus the last 3 problems, 9.5 and 9.6. Yeah. Okay, and then the test is short. There's I put up if you started the test, finish the one you're on, but then I created a slightly shorter version. Just taking 1 question off is all I did. So you can do the old version to finish up, the new version after that says chapter 9 at home exam. That's the one you want to do. Okay. What about these now? These are the problems. These are based on the problems from 9.1. These seem to be the hardest problems of all the chapter 9 problems for people to do. So let's focus on these just for a bit here. These are the ones that use properties of similar triangles. We've got 3 nested right triangles here. We've got a small, a medium, and then the whole thing is the large. Now there's some practical advice I can give you about this. First of all, if the small and the medium triangles are not really very different in the picture, draw them that way. You don't have to draw this to scale. You want to use and I'm not making this up, this is literally called the principle of exaggeration. You want to exaggerate the drawing so that you can see a really distinct difference between the sizes of all 3 triangles. So let's take this drawing and let's recreate it. We'll make this a little smaller, how about? And let's recreate this so it looks a little better. There's going to be the bottom, and then we'll go like that. Now, isn't that more obvious now? If I draw this line down here, that's more obviously small, medium, and large, right? Okay, so what we want to do then, there's 2 approaches to this. You can take your pick. I'm going to show you both on this first one, and you'll see that they're really the same thing. Let's write in all the distances that are given to us. Well, AD is 28, so this distance right here is 28. DC, sorry, which is this guy over here, is only 7. And we're looking for BD, which we'll just call X in our drawing. Right, make sense? Now what we want to do is we want to find what are out of those 3 triangles that are lumped together there, the small, the medium, and the large is the whole thing, which 2 of those triangles use 2 of those sides? Medium and small, right? The small uses those 2 sides, right? And the medium uses those 2 sides. The large one doesn't use 2 parts. It only uses 1. The large one involves 28 plus 7 is 35. But that's the only side of the large triangle that involves those 3 pieces of information that we're either given or trying to find. Agreed? So it's the small and the medium are the ones that we're going to focus on then, because those are the ones that each use 2 of those. And all we got to do is ask ourselves, now, which of those 3 sides is the one that's shared between the small and the medium? Is it, okay, BD, right? It's going to be X in this case. Not 28, not 7, but X. It doesn't have to be the unknown. It could be one of the given lengths, too. It doesn't always have to be X. In this case, it is. So X is the shared side. We got to ask ourselves, what 2 roles does it play? What part does it play? And when I say what part, I mean when we're talking about a right triangle, we can always think of the sides as being one of 3 things, right? Either the short leg, S, the long leg, L, or the hypotenuse, H. Well, what role does it play in the small triangle? S, L, or H?
L.
L, yeah. The hypotenuse is clearly over there, right? That's the one that's opposite the right angle. But X is clearly the larger of the 2 legs, so it's L. What role does it play in the medium triangle? S. Right, short leg. Okay, so then the ratio that we're going to set up for both of those triangles is involves S and L. It doesn't matter which one you put on top or which one you put on bottom. I always put the small one on the top and the big one on the bottom, but it doesn't make any difference. So we're just going to set up that ratio for the small triangle and for, in this case, the medium triangle, right? So in the small triangle, what is the ratio of short over long, S over L?
7 over X.
Yeah, 7 is the short, and X is the long, right? What about in the medium triangle? What's the short? The The short side is x, and the long side is 28. So now it's a piece of cake. Once I get that ratio equation set up, it's a piece of cake. What would I do with this? I'm just going to focus on this equation now. This is what oops, there's my ratio equation. How do I solve that? Cross multiply, like always. So that diagonal is going to give me x times x is x squared. This diagonal gives me 196. Good. And then how do I solve for x? Square root it. Good. So we know that x equals the square root of 196, right? Okay. How do I put that in Moodle? Yeah. The way we do square root in Moodle is just SQRT. So that's how we enter that in Moodle. And that's our answer. That's the exact answer. Yes, sir.
Put 14.
You can, because it's actually, if square root of 196 works out to be just an integer, yeah, put 14. Yeah. It won't always be that way, though. Sometimes, what if this was like the square root of 197, where it doesn't work out to be just a nice even integer? Then just put square root 197. Okay. Now, what's the other way to do that one? Well, I think this is the best way, the easiest way myself, is to establish what's the ratio, that the shared side plays what two roles, and then what are those two roles in our two triangles, right? And that sets up the ratio. An equally good, maybe slightly longer way to do this would be, let's just separate the triangles and draw them in the same orientation. So if I took the medium triangle, for example, that's the one that's got 28 and x. Let's just draw that by itself. Right? And then next to it, we'll take the small triangle and put it in the same orientation. So we can see that, that side goes with that side goes with that side. Now for the small triangle, remember 7 is the short leg, so that's got to go there. And x is the long leg. What we've really done is we've just taken this thing and just kind of done that to it with the small one, right? And then it's pretty easy to see then that when we set up our similarity ratios, small to big is 7 to x, right? 7 over x would equal x over 28. There's our ratio, right? And from there, it's the same as the other problem, other way we did it. Does that make sense? Okay. So take your pick. I mean, if worst case scenario, just write them separately, and it becomes a very simple problem. If I just draw the triangles separately and plug in the numbers, I can see right away what the correspondence is. Okay? Okay, what about this one? Same kind of thing. We'll just quickly go through this one. How about? First thing I want to do is draw it where it's more exaggerated. Okay, it looks like this is the one that's supposed to be the small triangle, isn't it? Right? And that's supposed to be the medium triangle. But they look almost the same size. That's harder to see. So let's redraw this. More like that. Right? Okay, and then this becomes 9, and that becomes 11, and this becomes x. Okay, so now this one's a little trickier. What are the two triangles that share, each of them uses 2 of those 3 parts?
The big one and the small one?
Big one and the small one, yeah. The small one, clearly, it's got sides of 9 and a hypotenuse of x, right? The medium one only uses 1 of those, but the big one uses 2. If I look at the big triangle, x is a side of the big triangle, and I know the entire hypotenuse of the big triangle would be what? 20. Yeah, I can just add those 2 up, right? 9 and 11 just gives me 20 for that whole thing, right? Makes sense? And so then what's the shared side this time? X. X plays what 2 roles? In the small triangle, it's hypotenuse, so it's going to be h, so that one of our 2 sides is going to be h. What part does it play in the big triangle?
Small.
Small. So we want the ratio of s over h. Okay? So So for the small triangle, what's that ratio going to look like? S over H? What's the short leg of the small triangle? 9, okay. And the hypotenuse, x. Now for the large triangle,
X over 20.
yeah, x is the short leg, and 20 is the hypotenuse, because that's what's opposite that right angle in the big triangle, right? And then I just cross multiply and solve, right? So if I cross multiply, I just get x squared equals 180. So what's x? Square root of 180. Which in Moodle would just be square 180. And we could, of course, we could also just, pull this small triangle out and set it right there and compare the two also, right? Take a pick. Okay. Now, what about this one? If I plug in the numbers on this one, AB is 37, AD is 21, and we're trying to find BD, so we'll call that X. How do I do that one?
Pythagorean theorem.
Yeah, I don't have to do anything fancy with that. That's old news. That's just Pythagorean theorem, right? All those three sides are in single triangle, single right triangle, so we can just use the Pythagorean theorem to set that one up, right? Well, how does the Pythagorean theorem relate to this? What squared plus what squared? Okay, so in other words, x squared plus 21 squared equals 37 squared. Subtracting 21 squared, we get x squared equals 37 squared minus 21 squared, right? And that's just calculator work. Okay, we can throw that in our calculator and get an answer real quick. So 37 squared minus 21 squared is that. And then I'll just square root that, right, to get x, agreed? So I get, I thought that would have worked out. It's not. So we get 30.46. Okay. And they want us to round to the nearest hundredth, so we just rounded 2 places. That's it, 30.46. Okay, questions? Make sense? Oops. Okay, what about this one? I'm not going to do the whole problem, but this one looks hard, but it's not at all. It's really simple. If we're trying to find the blue area, how do I find the area of a triangle? Half base times height. Good. Now, when we have a right triangle, we want to just make sure that we're picking our base and our height carefully. Do we want to use AC as the base? No, we don't. AC is not a good base, because if I use AC as the base, then that makes the height, that distance right there, which I don't know. Yes? Yeah. Okay, so instead, what I want to do with this one is I want to flip it around like that, don't I? So that's how we set the triangle up. Where here is the base, right? And there's the height. Now, it's hard to read this, but it's telling us that AD is 33. So this distance right here, let's write these in. So this distance is 33. Is telling us that BD, so this distance, is 16. And it's asking us for this distance. No, it wants the area. Never mind. So we need that distance, don't we? Let's call that x. Now, how would I find x? Okay, we're going to set up similar right triangles. And the shared side here, we've got 2 triangles. The small and the medium each use 2 of those 3 parts, right? Agree? The shared side is x. That plays the role of, in the short triangle, it's going to be the long leg, right? In the medium triangle, it's the short leg. Agreed? And so this becomes just like the problems we just did. We don't even probably have to do this problem. We could just maybe set it up. So we know that the ratio of short over long equals, for the small triangle, it's just going to be 16 over x. For the medium triangle, it's just going to be x over 33. So cross multiply, right? X squared equals 16 times 33. Square root it to get your answer for x. And then what am I really trying to find?
Area.
Area. So I'll just do 1/2 times 33 times whatever x is. Right? Make sense? Okay. Just so we can get through everything here. We won't even finish that one. You could all finish that on the calculator. That's no big deal. Okay, did that. Okay, these story problems, don't make them harder than they are. They're actually easier problems than the other ones. It's just that there's a picture instead of a story, instead of just a triangle that's given to you. All you have to do is just fill in the blanks, right? So in this case, let's see, what do we get here? We're told we're climbing this rock. We want to know how high the rock is. And they give us all this information. They tell us that we're, what do they tell us here? They tell us that we're, maybe I need to scroll down a little bit. We're 21 feet from the rock. So x is 21, so let's fill that in. So this distance is 21. This distance is 5.7, and we're trying to find the whole thing.
So from the ground towards that side?
Yes, from the ground. So that leg right there is 5.7. Okay, we're trying to find the whole thing. Now, how can we do that?
Use the little
Little triangle and
medium.
how about the little and the medium? Good idea. If we use the little triangle and the medium triangle, well, that distance right there, we'll just call that x, how about? If I found x, I could find the height of the rock by just adding 5.7 to x, couldn't I? Right? And then this becomes the same kind of problem we've been dealing with, right? I've got a small triangle and a medium triangle, each of which shares the side that's 21, right? So what if let's try this one by just drawing the two triangles. We've done the ratios last couple times. Let's just draw these triangles next to each other. So if I take the medium triangle, there it is, 21 and x. And if I take the small triangle and line it up the same way, then 5.7 is less than 21, isn't it? 5.7 is the short side. 21 is the long side. Everybody see that? Right? And so what we want to do then is we want to just set up a similarity ratio, right? Small to big, 21 to x equals 5.7 to 21. Right? Just cross multiply and solve for x. Okay. Make sense? And then once I get x, what do I do?
Add it to
Add 5.7 because I want the whole height of the rock, right? So the one thing about the story problems you can't forget is they're asking a specific question about the picture. So you got to take your mathematical answer and say, now how does that give me the answer to the actual story, right? So once we know what x is, once we get a number to put in for x, we'll just add 5.7 to it. Okay? Are we okay leaving that one there? Does that work? Should we finish this one?
no, it's
I think you're okay.
Okay, all right. Okay, these kind, extremely simple. So we've gotten through the hard part. That's all that other stuff. 9.1 was clearly the hardest stuff for people. The rest of this is very simple. Now, the 30, 60, 90 triangles, the special triangles, and the 45, 45, 90 triangles, one thing I want you to know about those is you can do those using SOHCAHTOA. You don't actually have to know the magic numbers. It just makes things a lot shorter and easier. All those problems could be done the way we're going to do some examples real soon using SOHCAHTOA stuff. But if you remember the numbers, much, much easier. So now, what are, in a 30, 60, 90 triangle, what are the magic numbers? One of the numbers, you tell me, what sides do the numbers relate, and what are they? Square root of 3 goes where? Well, that relates what two sides?
Y and x.
Okay, y and x, the short and the long. Good. So the magic number that connects these two sides is the square root of 3. Okay, what's the other one? 2. What two sides does that connect?
Short.
Yeah, good. Short and hypotenuse. So we've got that magic number. Now the way we use the magic numbers is very simple. You multiply when you're going from small to big and divide when you're going from big to small. That's simple. So in this case, if we're given that y is 51 and we want to find x, what do? Yeah, we're going to go from a bigger side to a shorter side, right? So we're going to divide by the square root of 3. That's it, right? So we would get the answer x just equals 51 divided by the square root of 3. In our, we're going to round it. Put it in our calculator and round it. Now, what if we want to find z?
Times it by 2.
Yeah, I'll take this answer. Whatever we get for x, I'm going to multiply by 2, right? Now, if I want to go from y to z, or vice versa, I have to go through the short side, don't I? Because the special numbers, the magic numbers, always connect to the short leg. Okay? So z would just equal 51 divided by the square root of 3 to get there, right? Times 2 to get there. Okay? What if I was given z and wanted to find y? What would I first do? Divide by 2 to get there, and then multiply by the square root of 3. Piece of cake. Okay. 45, 45, 90, even easier. The only magic number we have is only one of them. And that's the one that connects either of the two legs, because they're the same size, right, to the hypotenuse. What is that magic number?
2.
Square root of 2. Right? And then if we made a magic number that connected x and y, what would it be?
2.
No.
4.
No. 4. How come?
They're the same.
They're the same. Yeah, we don't even need that one, but they're the same, right? So if we're given that x is 92, what if they ask what y is? What's y? 92. Yeah. What about z? How would I get z? Good. I'm going to multiply because I'm going from small to big, right? A shorter side to a longer side. So I multiply by the magic number, square root of 2. Throw up my calculator. Done. Okay, these guys. These guys. Now, if you can do these, these are actually really important. This is the SOHCAHTOA stuff. Everything from the SOHCAHTOA stuff, if you can correctly write the word SOHCAHTOA, that's about 90% of the battle. So we're going to do SOHCAHTOA. Okay, now how do we know it's a SOHCAHTOA problem? Well, if we just draw the triangle and fill in the stuff, it's the only kind of problem it could be. So they tell us here that angle B is 90 degrees, so we'll call that vertex B. They tell us that angle A is 48, so let's go ahead and call that A. And then this must be C, right? And then they tell us a side length. AC is 347. Okay? What we're trying to find is AB. So this side length. So if this is the unknown, all we've got to do is set up our SOHCAHTOA equation and then solve it. Very, very simple. So now we got to ask ourselves, from the perspective of the acute angle up here, 48 degrees, right? So this is the one we're focusing on, is A. Right there. From the perspective of A, how would we label the sides of this triangle? Meaning, for SOHCAHTOA stuff, are they opposite, hypotenuse, or adjacent? Right? And we know that that's how we're labeling them because those are the letters that show up in SOHCAHTOA. O and H and A, right? So which one is the hypotenuse? 347. It's always opposite the right angle. So that's obviously H. Now what about the O and the A? That's going to depend on the angle. From angle A's perspective, which side is opposite? Okay, BC. So that's O. And then adjacent means next to. So the leg that's next to 48 is that one. Okay, now in my equation, I want to use the side that we're given and the side that we're trying to find. So that's going to be these two, right? So all I want to do is find the SOHCAHTOA relationship that involves A and H. Which one is that? Yeah, it's the cosine one. There's my A and my H, right? So that's it. So we're just going to say then that the cosine of the angle, right, that we're focusing on, it's from the perspective of angle A. So the cosine of angle A just equals the ratio of opposite over adjacent. Well, opposite is, oh, I'm sorry. Sorry, that's not right. Strike that. It's adjacent over hypotenuse, right? So what's the length of the adjacent side?
X.
X. Hypotenuse?
347.
347. And remember that cosine A is oh, I know what A is. That's 48. So I can plug in that number, right? So it's the cosine of 48 degrees equals X over 347. And the cosine of 48 is a calculator number. I just put that in my calculator and get an answer, right? So how do I solve for X here? How do I get the X by itself? How do I undo dividing by 347? Multiply by 347. So I just get X equals 347 times cosine. Wow. 48 degrees. Calculator work. So if I put that in my calculator, what mode do I need to be in?
Degree.
Degrees. Let's check. Oops, wrong one. Mode. Yeah, I'm in degrees. Okay, that's good. And then I just do 347 times cosine 48. There it is, 232.19. That's my answer. Okay? All right, now what about really the last problem we have to do, and anything else will just be kind of gravy here, but is that one. I think, hang on. Yeah, I don't want to do that one. Okay, let's just do this one. This is 9-6 is nothing new. All we're doing is filling in all the blanks on this triangle. So here's our triangle. We got to draw the triangle. They tell us angle B is a right angle. They don't tell us any of the other angles. They tell us if we call that A and that C, they tell us that side BC is 72 and side AB is 65. I got to fill in all the other stuff. I need the missing side length and both of those missing angles. Okay. First of all, how can I find the missing side length? Yeah, very simple, Pythagorean theorem. I'm given two sides of a right triangle. I find the third with the Pythagorean theorem. So we could just say 65 squared plus 72 squared equals, if we call this x, equals x squared. And so that's just calculator work. So we'll just find out what is 65 squared plus 72 squared. Gives us that. If I square root that, I get 97. Okay, so x is 97. So I can fill that in. So side AC, 97. Piece of cake. That's old stuff. Now, how do we get the angles? Here's the one last part that was a little bit new. How do we get these angles? What if I want to find, for example, angle A? Okay, now if I want to find angle A from the perspective of angle A, I need to set up the SOHCAHTOA relationship that applies. So from A's perspective, that's obviously the hypotenuse. Which side is opposite of A? 72. So that's opposite, and then that would be adjacent. 65 would be adjacent. Now let's go ahead. We could use 97 because it worked out perfectly, but let's just use the original two sides. How about 72 and 65? That involves an O and an A. So which SOHCAHTOA relationship do we want then? Tangent. Yeah, that's got the O and the A in it. So we're using tangent. Okay. So then our equation just becomes tangent of angle A is the ratio of opposite, which is 72, right? Divided by adjacent, which is 65. Agree? Now, what was the trick here? If I want to solve for A, what was my trick for undoing a tangent? What do I do to both sides? Remember, if this was x squared, I would undo the squared by square rooting, for example. How did I undo a tangent? Yeah, an inverse tangent, right? So then I know that A is going to equal the untangent, really, the inverse tangent of this side. Right? Does everybody see what we did there? That's like an algebra step. Untangenting or inverse tangenting. Got the A by itself, but we got to treat both sides equally. So on the other side, we've got the inverse tangent of that fraction. That's a calculator thing once again. You know, how did we get to the inverse tangent on our calculator?
Second.
Tangent. Yeah. So inverse tangent of 72 divided by 65 is 47.92. Right? So we can fill that in. Let's go to our table. That was angle A. So 47.92. Now, how do I find angle C if I know what angle A is?
Add them all together and it's 180 subtract.
Okay, good. So I know that they all add to 180. If the right angle is 90, what do the two acute angles always add to? Well, the two, just A and C would add to 90. Good. So couldn't I just subtract angle A from 90 to find angle C then? Right? Calculator. All I have to do is just take 90 minus that last number, right? Enter, and there it is, 42.08, right? Because that 5 pushes that 7. Does that make sense? The 5 after the 7 pushes the 7 up to an 8. So 42.08. And those two add to 90, so it works. Okay? Make sense? All right. Okay, now, I'm not going to do, that's the same stuff. I'm not going to do this one necessarily, but I wanted to show you that it's easy. It's a story problem, yeah, but it's very simple. All this is just a SOHCAHTOA problem, right? We're just setting up a right triangle where x is what? They're telling us that the measure of angle B is 50, right? So that's a 50-degree angle. They're telling us that y is 49, and we're just looking for that, right? So if we're trying to find x, what's the SOHCAHTOA relationship in this right triangle that's going to involve those two sides? What's that going to be? From the perspective of 50, isn't that opposite and that adjacent? Tangent, right? So this is just a tangent problem again. No big deal, right? Okay. Does that make sense?
Is that for us to go?
Let me check.
Because there's people watching.
Sorry. That's our last ride.